Okay, 16 review. Number 1. A box contains 10,000 tickets. 4,000 of them are zeros and 6,000 of them are ones. And 10,000 draws will be made at random with replacement from this box. Which of the following best describes the situation and why? So the number 1 will be 6,000 exactly. Is that true? No. We would expect it to be close. The number of ones is very likely to equal 6,000, but there is also some chance that it will not be 6,000. Is it very likely that we get exactly 6,000? No. But we expect the percent error to be very, very close to 0. We don't expect it to be 0. We just expect it to be close to 0. So 3, the number of ones is likely to be different from 6,000, but the difference is likely to be small compared to 10,000. Okay. What if we change the box and we put 4 zeros and 6 ones in there? Is anything going to change? No. If you have 4 zeros and 6 ones, or 400 zeros and 600 ones, or 4,000 and 6,000, it doesn't matter. Okay. You could even put 2 zeros and 3 ones in and get the same deal. Okay, 2. Repeat exercise 1 for 10,000 draws made at random without replacement from the box. It will be exactly 6,000. How come? You're going to draw everything out. And there are exactly 6,000 ones. 3. A gambler loses 10 times running at roulette. He decides to continue playing because he is due for a win by the law of averages. A bystander advises him to quit on the grounds that his luck is cold. Who is right, or are they both wrong? They're both wrong. Because every roulette result is independent of every other. They did? Awesome. Okay, cool. So yeah, losing a lot does not mean you're going to lose more, and winning a lot does not mean that you're going to win more. Every one is independent. 4. A die will be rolled some number of times, and you win $1 if it shows up as a 1 more than 20% of the time. Which is better, 60 rolls or 600 rolls? So how likely is it to get a 1 on a dice? 1 out of 6, which is about 16%. Okay, so is 20% likely? Not as likely as 16. So if 20% is not likely, do we want to play a lot of times or a few times? A few times. 60 would be right. Okay, really, we would rather roll once, right? Because the more you play, the absolute error is going to go up, but the percent error is going to go down. So if we are playing a losing game, we want to play as few times as possible. Okay? As in A, but you win $1 if the percentage is more than 15. 600, how come? We would expect 16.6%. So more than 15% is very likely, especially if we play the game a lot of times. In fact, if you played it 10,000 times, you're pretty much guaranteed to win, because that error should be so close to 0 by the time you get to 10,000 that you're guaranteed to win. So this is where we want to hit. Okay? Percentage-wise, that's where we want to hit. Okay? So 20%, the more we play, the closer we're going to move into this realm. But the distance, or sorry, the number of errors is going to go up the more we play. So if we play 100 times, we would expect our error to be something like 10. I'm just making this up. But if we played 10,000 times, our error is going to be a lot bigger. It's going to be 100. Right? Because when I multiply this by 100, I multiply this by the square root of 100. So we're further from the expected value. But when you compare this number to this number, it's much smaller than when you compare this number to that number. So the distance from the expected value is likely to go up, but the percentage is likely to be even closer and closer to 16.6, right? And we know that the rule is about the square root of the product of the factor. So definitely for B, we want to play 600 times. We would rather play 1,000 times, because the more we play, the more we're closer to 16.6. Okay, C. As in 20, but you win the dollar if the percentage of aces is between 15 and 20. So between 15 and 20, does that capture the average? Yes. So we want to play many times. They're actually both pretty likely, but the more we play, the closer we get to this number, and the fewer times we play, the further we are expected to be from that number. As in A, but you win the dollar if the percentage is exactly 16.6. That's the, so what's the chance that we get exactly 1 in 6? Is that, sorry, are you more likely to get exactly 1/6 if you play a few times or lots of times? A few times. Remember, because that distance from the expected goes up, but your percentage is going to go down, but we would want to play 60 times. In fact, we would rather play 6 times, because in 6 rolls, you're much more likely to get 1 than getting 10 in 60 rolls. Does that make sense? Okay. 5. True or false? If a coin is tossed 100 times, it is not likely that the number of heads will be exactly 50, but it is likely that the percentage of heads will be exactly 50. So if you toss a coin 100 times, are you likely, is it expected you're going to get exactly 50? No. We would expect it to be close to 50, but not exactly 50. But it is likely that the percentage of heads will be exactly 50. That's the exact same thing, right? 50%. So they're the same, and it's false. We would just expect it to be close. Okay? And the more times we roll, the closer we are to 50%. All right, 6. According to genetic theory, there is very close to an even chance that both children in a 2-child family will be of the same sex. Here are the 2 possibilities. So, what does an even chance mean? If you look at every family that has 2 kids, about half the time, the kids are the same gender. Okay? Here are 2 possibilities. 15 couples have 2 children each. In 10 or more of these families, it will turn out that both children are of the same sex. Yes. Shh, hold on. Good. Don't say that yet. That's what I was going to compare it to. And 2, 30 couples have 2 children each. In 20 or more of these families, it will turn out that both children are of the same sex. Which possibility is more likely, and why? Okay, so 10 over 15 simplifies to be 10 over 15 simplifies to be Two. Yeah, 2/3. Yeah. No, you're fine. And then 20 over 30 turns out to be 2/3. So we would expect how many with 15? If we looked at 15 families, what would we expect? 7.5, so 7 or 8. If we looked at 30 families, how many would we expect? So what it's saying is, if you look at these families that have 2 kids, so you can either get male, 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 female, female, male, and female, female. How many of those have the same gender? 2. So basically, we win here, and we win here. These are different though, right? The older one is a male, and the older one is a female. So those are 2 different. It's just like coin flipping. HT and TH are not the same thing because they're different kids. Right? One is older than the other. So in one, if you have 15 couples, if you look at 15 families, how many would you expect have same gender children? 7 or 8. Half of them. Can't have 7.5, so 7 or 8. Okay, if you had 30 families, how many would you expect to have same gender? 15. So what we're looking at is it more likely to look at 15 families and have 10 or 30 families and have 15? Nope, wait, was it 15? 20. 20. So we expect 50%, and in each of these we get 66%. Okay, so which one is more likely to find? The 15 or the 30? Well, do we expect when we look at more and more families, we expect the percentage to get closer and closer to 50. The more families we look at, the closer we would expect to get to that number. Okay, so the answer is no. Okay, let's try this again. The more couples we look at, we would expect to be close to this number. So if we want to be far away from that number, we need to look at as few families as possible. Which one is more likely? The 15 is more likely because the percent error is expected to be high when we have fewer couples. But does everybody understand that? This is exactly what we did in the last problem. We just looked at it in a different way. 1 is the answer. Yes. If this number is going to be higher than the expected, then we are going to choose as few families as possible. Okay? When we get up to 30, we would expect the percentage to be even closer. What if we looked at 10,000 couples? It would probably be very close to 50%. If we looked at 10 couples, we'll probably not be as close to 50%. Okay, 7. A quiz has 25 multiple choice questions. Each question has 5 possible answers, one of which is correct. A correct answer is worth 4 points, but a point is taken off for each incorrect answer. A student answers all the questions by guessing at random. The score will be like the sum of 25 draws from the box. All right, so we're going to build a box. Okay, we are going to make 25 draws. Okay, Of those 25 draws, what does the, or sorry, we're going to make 25 draws out of the box. It's just 25 multiple choice questions. Okay? So, when we draw out of the box for question number 1, what are our possibilities? So we could either get, let's say, so we have A, B, C, D, and E. Let's say C is the correct answer for question 1. How much do I get if I guess C, or if I answer C? I get 4 points for C, for this one, and then how much for the others? -1 for A, and -1 for B, B, and then -1 for D, and -1 for E. Right? That is question 1. What about question 2? It's exactly the same, but the letters might change. So if I erase the letters, basically it's going to be a +4 ticket, and then there are 4 -1 tickets. That's what's in the box, and we're going to replace. Right, there is 1 right answer, which is 4 points, and 4 wrong answers, which are -1 points. Okay? Is guessing worth it on this game? No, why not? Does it matter if you guess? So let's say we make 5 guesses. What do we expect in 5 guesses? 1 right answer, which is +4, and 4 wrong answers, which is -4. We end up with 0. So is guessing worth it? It doesn't matter. Statistically, it doesn't matter. Right? If you were to guess A on every question, statistically, what would your score be? 0. Right? Right. So what I'm saying is, if you guess A, if you write down A for every question, and the answers are scrambled, right? You would expect to get 0 points on the test or quiz or whatever it is, because you're going to win 5 times. 5 times 4 is 20, but you're going to lose 20 times. So if you play 25 times, you're going to get each one of these 5 times, right? So you'll get 5 right answers, which is 20 points, but you're going to get 20 wrong answers, which is -20 points. That's how the game would be played. Okay? So fill in the first blank with a number. Oh, we got it. Now, so is there a way you can improve your chances by guessing? Let's say you read question A. Is there a way, if you don't know what the answer is, to make your chances higher? If you can eliminate some of the incorrect answers, then guessing would be worth it. Yeah, kind of. So I look at question number 1, and I don't know if it's A, B, or C, but I know it's not D, and I know it's not E. Should I guess? Yes, because you have a 1 in 3 chance of winning and only 2 chances of losing, so that's 4 points versus -2 points. Does that make sense? If you could eliminate one possibility in every question, then guessing would be right. So if I know that E never happens, then I could take these 5 guesses and I could spread them out. +1, +1, +1, +2. And now 6 times 4 is 24, and I have 6, 6, that's 12, and 7 more is 23. No, is that right? Yeah. So now if I guess, I should end up with a +1. Okay? Or if I happen to have this a +1 and this be a +2, then you'd even do better. All right, 8. A gambler will play roulette 50 times, betting $1 on 4 joining numbers each time. So 23 through 27 and so on. If one of these 4 numbers comes up, she gets the $1 back together with a winning of $8. If any other number comes up, she loses the $1. So the bet is pays at 8 to 1. And there are 4 chances in 38 of winning. Her net gain in 50 plays is like the sum of, it's going to be 50 draws. What does the box look like? So I'm going to have an $8 ticket 4 times. What do the other tickets look like? So I have negative $1 tickets. How many times? Well, how many tickets are there total? 38. So this would be 34. And I'm going to make 50 draws. Okay. First off, does the casino have an advantage? Well, let's see. What is 4 times 8 plus 34 times negative 1? Well, 4 times 8 is 32 minus 34 is negative 2. What does that number mean? If you play the game, not 50, 38 times, you would expect to lose $2. So I played 4 times and won, and I played 34 times and I lost. So you can actually figure out your expected loss per play. If you took $2, if we took $2 and divided by 38, you expect to lose 5.2 cents per dollar. Does that make sense? So the casino has a 5% advantage in roulette for most of what you do in roulette, a 5% advantage. So if you play 50 times, how much do you expect to lose? You would expect to lose $2.63. So if you were at the roulette table and you bet on red and you just kept betting red and you played 50 times, you would expect to come out $2.63 in the hole. No. So really, I mean, you can't, yeah, it'll be 2 or 3. More likely 3. Okay, 9. A box contains red and blue marbles. There are more red marbles than blue ones. Marbles are drawn one at a time from the box at random with replacement. You win $1 if a red marble is drawn more often than a blue one. So we have more red marbles than we have blue marbles. Okay, and we win if when we draw out, we end up with more red draws than we have blue draws. Do I want to draw 100 times or 200 times? 200. How come? Is more red expected? Yes, so we want to draw more. What if blue is expected more? Then we want to draw fewer. So 200 because more red is expected, so we want more draws. Yep. If you want to get the expected, you want to play more, which is why the house wants everybody to play roulette, because the house is expected to win. So the more people play, the more the house wins. If everybody showed up and just, well, I guess if everybody did, it would be different, but if the only person who played roulette that day bet on one color once with all of his money and then left, the casino might lose a lot of money. Right? The casino wins when people play a lot, because then you're closer to the expected value. Okay, choose one of the 4 options below and explain your answer. So A gives a better chance of winning. No. B gives a better chance of winning. Yes. A and B have the same. No. Can't tell. Oh, I see. Those are just. So, yeah, 2. All right, number 10. 200 draws will be made at random with replacement from that box from -3 to 3. What do we expect the average to be? Or sorry, what do we expect the sum to be if we draw a lot? 0. Because all the negatives should cancel all the positives. If the sum of the 200 numbers drawn is 30, what is their average? So we draw 200 times, and we end up with the number 30. What can you tell me about the draws? There were more positives than negatives, right? Some of them canceled out. Some of them were 0 and some of them canceled out. But if we ended up with 30, then we had more positives than negatives. Okay, how do you find an average? The average is just the total divided by the number of draws. So it'd be 30 over 200. So 30 divided by 200 is 0.15, which is slightly more than 0. Oh no, so the average is just 0.15, which means we had slightly more numbers to the right than we did to the left. If the sum of the 200 numbers is -20, what is their average? -0.1. Yep. In general, how can you figure the average for the 200 draws if you're told their sum? Just divide it by 200. Right? The average is the sum divided by the number of draws. D, there are 2 alternatives. Winning $1 if the sum of the 200 numbers is between -5 and +5. Winning $1 if the average of the 200 numbers drawn is between -0.025 and +0.025. So the first one is sum, and the second one is average. What do we need to do in order to figure this out? We need to either make them both sum or make them both average. So 5 divided by 200, oops. Which means they're the same. Now, what if, so it would be same, what if we change number 2 to the sum? Well, first off, it can't happen, right? There are no decimals. So what if 1 said ±5 and 2 said ±1? Which one is more likely to happen? So if you had to choose between ±5 or ±1, which game would you play? So you win. So if I have 0 here, you either win if you're in there, or you win if you're in there. The 5, you're more likely to win in the 5 because it's a wider range. All right. That is 16A. Nope, 16 review.